friends, today I will explain you exercise number 8.4. So let's start it. Question number 1. Express the trigonometric ratios sin A, sec A and tan A in terms of cot A. This question can be asked in different way even. Means if value of cot A is given and in question you need to find the sin A, sec and tan A. For that we have one method that we learn in exercise 8.1, one triangle method. But if we do not want to use it, then we can go for this method. In this method, you can get formula of sin A, sec A and tan A in terms of cot A by using the identities. Right? So first of all, we need to recall that three identity. First one is sin square theta plus cos square theta is equals to 1. Second one is 1 plus tan square theta is equals to sec square theta. And third one is 1 plus cot square theta is equals to cosec square theta. So first of all, we need to convert sin A in terms of cot A. Right? Now, what is the relation between sin and cot in identity? So one identity is there, 1 plus cot square A is equals to cosec square A. Right? Now from this identity we can get the formula of cosec A in terms of cot A. After that we know one thing, that is cosec A is inverse of sin A. So from cosec A we can find out our sin A. Right? So first of all we use that identity, that is 1 plus cot square A is equals to cosec square A. Now convert cosec A into sin. So cosec is inverse of sin. So in place of cosec A we can write like this, 1 upon sin A. Right? So that I use here, 1 upon sin A. But here square is there, cosec square A. That's why answer is 1 upon sin square A. Because in numerator 1 square 1, we can do square to the both the side. Okay. So in place of cosec square A, I written here 1 upon sin square A. Right hand side as it is, 1 plus cot square A. Then we need to find sin square A. Right? So take inverse from both the side. So here 1 upon sin square A. So sin square A means denominator goes in numerator and numerator goes in denominator. So it will be converted into sin square A by 1. But no need to write 1 in denominator. That's why here it is only sin square A. Now right hand side, here nothing is denominator, that means 1. 1 plus cot square A by 1 we can write. Then change the numerator and denominator. So it will convert into 1 upon 1 plus cot square A. That is written here. Right? Sin square A is equals to 1 upon 1 plus cot square A. So we take inverse to both the side. Then from sin square A, if we need to find sin A, then we need to take square root. So we are taking square root in both the sides. So sin square A, square root of sin square A is equals to sin A, and here square root. So under root of 1, it is 1, right? And in denominator it is in square root 1 plus cot square A. So final answer is sin A is equals to 1 upon under root 1 plus cot square A. Right? So here sin is converted into cot. Now second thing, it is sec A. Right? Here we have two ways. From sin A we can find cos A, because one identity is there, sin square theta plus cos square theta is equals to 1. And from cos we can convert it into sec. Second thing, it is the second identity, 1 plus tan square A. 1 plus tan square A is equals to sec square A. Now in place of tan square A we can write 1 upon cot square A. Right? Because tan is inverse of cot and cot is inverse of tan. So in place of tan A we can write like this. That means 1 upon cot A. Right? So that we use here. So here we can get sec in terms of cot A. So use this identity sec square a is equals to 1 plus tan square a. Then in place of tan square a, write its inverse, that means 1 upon cot square a. So now take LCM. So cot square a multiply 1, it's a cot square a, and here plus 1 as it is. And in denominator cot square a means our LCM. So what we get, that is 1 plus cot square a upon cot square a. Now here left hand side sec square a is there, so take square root. So in right hand side square root of numerator, it is already written in numerator 1 plus cot square a. But in denominator cot square a is there and square root of cot square a. So square is cut with square root, because we can write like this under root cot square a. If we write in terms of exponent, that it becomes 1 by 2. Square root means exponent 1 by 2, then this 2 to exponent cut, and finally we get cot a, right? So this is our second answer, means our sec a in terms of cot a. Now third thing, it is tan a. Tan a is simply we can write like this, tan a is equals to 1 upon cot a, because tan is the inverse of cot and cot is inverse of tan. So it is directly converted into cot a. Tan a is equals to 1 upon cot a. Done. Question number 2. It's a similar type question like question number 1. So question number 2 is write the other trigonometric ratios of angle A in terms of sec A. Total 6 trigonometric ratio we have: sin theta, cos theta, tan theta, cosec theta, sec theta and cot theta. And sec A is one of them. So we need to convert other 5 trigonometric ratio in terms of sec A. Right? So first of all, we start with cos A. Cos A is easily converted into sec A, because cos is inverse of sec is inverse of cos. So we can write like this: cos A is equals to 1 upon sec A. Whenever inverse are there, we can write like this. Okay, cos A is equals to 1 upon sec A. It is easily converted, and we also learned this formula in our theory part, right? So first term is done. First ratio is done. It is converted into sec A, right? Now for sin A, use the identity sin square A plus cos square A is equals to 1 and convert cos into sec. First of all, here we are trying to find sin square A. So transfer cos square A to the right hand side, right? So right hand side already 1 is present, and plus cos square A transfer to the right hand side, it becomes minus cos square A. So sin square A is equals to 1 minus cos square A. Then put the value of this cos A. Cos A is equals to 1 upon sec A. So cos square A is equals to 1 upon sec square A. Now take LCM. So this is sec square A multiply with 1, it's a sec square A minus 1 upon our LCM, it is a sec square A. Now here sin square A is there. We are finding sin A. So take square root from both the side. So sin square A, it becomes sin A, and square root right hand side. So square root of numerator, it is already written in square root, right? Sec square A minus 1. And in denominator, again it is a sec square A. So square root of sec square A, this exponent and square root cut. So finally sec A. So it is written in sec A, right? In numerator, 2 things is there. Here sec square A minus 1. We cannot think like this. Square root of sec square A is sec A, and square root of 1, it's a 1. No, this is wrong, because we need to take square root of this full polynomial, right? We cannot take a separate square root. If here all square is there, at that time we can cut this square root with this exponent. But right now square is not there. Okay, so we cannot directly write our answer, means we cannot find out square root of sec square A minus 1. Right? Here we need all square. Only in that condition we can find square root, but here square is not there. We cannot take a separate square root, right? Because under root x plus y. It is not equals to under root x plus under root y. It's wrong, right? Because just find out square from both the sides. So here you get x plus y if you take square of left hand side, and if you square the right hand side, then it becomes under root x plus under root y all square, and your answer is x plus y plus 2 under root xy. So this is one extra term. That's why we cannot write like this. Okay. So just take a note of it. Then third trigonometric ratio, it's a 10a. 10a is also easily converted into sec a, and I think we already write this formula in our theory part, because one identity is there. 1 plus 10 square a is equals to sec square a. We are finding 10 square a, so transfer this 1 to the right hand side. So sec square a is already present, and plus 1 transfer to the right hand side, it becomes minus 1. And after that we are finding 10a, so just take square root. So 10a is equals to square root of right hand side, it's a sec square a minus 1, right? So 10 is also easily converted into sec under root sec square a minus 1. Then cosec a. Now we already have this formula, sin a is equals to under root sec square a minus 1 upon sec a. So we can easily get cosec a, because cosec a is inverse of sin a, right? So cosec a, we can write 1 upon sin a. So we can write like this, 1 upon answer of sin a. Now answer of sin a is here. Okay. Now what we need to do, we can directly write answer, because if we change the numerator and denominator of sin a, we can get cosec a, right? We can directly write our answer. But if you write like this, then denominator's denominator means sec a goes in numerator. So final answer is sec a upon square root of sec square a minus 1, right? Then at last cot. Now we can also easily convert cot into sec, because we already know the answer of 10. Now cot a is inverse of 10, so we can write like this, 1 upon 10a. So in denominator write the answer of 10a. So we can get this 1 upon under root sec square a minus 1. Question number 3. Internally two questions are there. Evaluate. First is sin square 63 plus sin square 27 upon cos square 17 plus cos square 73 degree. So here now look at one thing, that is the addition of 63 plus 27 is equals to 90, and we also don't know the value of sin at the 63 and 27, right? And in denominator here 17 plus 73, it is 90. So we need to use method of that complementary angles, right? So first of all, in numerator we need to convert any one term, right? So here I am going with second term. So my first term is as it is, sin square 63. Now convert second term. So here 27 is there, so I can write like this, sin square 90 minus 63, because 90 minus 63 is equals to 27. Same thing in denominator, we need to convert one term. So here I am going with first term. I convert first term, and my second term cos square 73 is as it is. In first term here 17 is there, so I can write like this, 90 minus 73, right? Now what is the formula? That is a sin 90 minus theta is equals to cos theta. One more thing, if here square is there, means sin square 90 minus theta, so answer is cos square theta. We can use this formula in square even, in cube even. Okay, whatever exponent our left hand side is have, that we need to give, that exponent we need to give to our right hand side, right? So here sin square 63 again as it is. But answer of this 90 minus theta, theta is equal to 63. My answer is cos square theta. So cos square 63 because theta is equal to 63. Now in denominator, cos 90 minus theta, sin theta, here square is there, that's why square, and theta is equal to 73. So sin square 73, then plus my second term as it is cos square 73. Now in numerator, it is the form of sin square theta plus cos square theta, right? Because theta is same 63 in numerator, so sin square theta plus cos square theta. So I can write 1 in numerator. Same thing in denominator. Again my angle is same 73. Again it is the form of sin square theta plus cos square theta. So I can write here 1. So 1 by 1 is equals to 1. Then second question. So answer of first question is equals to 1. Now second question. Sin 25 into cos 65 plus cos 25 into sin 65. Again if we look at carefully, then here 25 plus 65 it's a 90. Here 25 plus 65 again it's a 90. But here same angle is given. Same angles are given 25, 65, 25, 65. So we just try to convert all this angle into same angle. Means either we can convert all this angle into 25, otherwise we can convert into 65. Right now I am going with angle 25. So I will convert all this angle into 25. Okay. So first term 20, it is already have angle 25. So it is as it is sin 25. But here 65 angle is there, so convert it. So I can write like this 90 minus 25. Then plus cos 25. It is already have angle 25, so as it is, and convert this 65. So I can write like this 90 minus 25. Right? Again, first term as it is sin 25. Now here cos 90 minus theta. Answer is sin theta. Theta is equals to 25. So answer is sin 25. Plus again here cos 25 as it is, sin 90 minus theta, cos theta, theta is 25, so answer is cos 25. Okay, now in first term sin 25 into sin 25, so I can write sin square 25. In second term cos 25 into cos 25, cos square 25. Now here is the form of sin square theta plus cos square theta, because angle theta is equals to 25. Right, so sin square theta plus cos square theta. So my answer is 1. Right, done. Question number 4. Total 4 internal questions are there, and it is MCQ type question. First question is 9 sec square a minus 9 tan square a. So we can take 9 as a common. So 9 common, then in bracket what is remaining? It is so 9 is common, so 9 cut. So in bracket sec square a, then minus sign and tan square a. Right? So 9 in bracket sec square a minus tan square a. Now what is our identity? 1 plus tan square a is equals to sec square a if we write in terms of angle a. Now transfer this tan square a to the right hand side. So here 1 is equals to sec square a minus tan square a. So sec square a minus tan square a. Answer is 1. So use that answer. Sec square a minus tan square a 1. So 9 into 1. Answer is 9. 9 ones are 9. Option B is correct. Right? Second question. In first bracket 1 plus tan theta plus sec theta, and in second bracket 1 plus cot theta minus cosec theta. Here in this question nothing is given, means the value of one trigonometric function is not given, value of angle is not given. Then we cannot go for the triangle method, we cannot go for the complementary angles method, we cannot go for the trigonometric value table. So only one way is there, that is we need to use the identity, and we can use the inverse formula. Okay, Now in this type of question, if we do not get any idea, means what we have to do. So first of all, try to convert our question in terms of sin theta and cos theta. If we do not get the idea on that time, okay. If we get the idea, then no need to do this. Here we go for the conversion of sin theta and cos theta. So convert this all question into the sin theta and cos theta. One as it is tan theta. Formula of tan theta is equal to sin theta upon cos theta. We already learned in our theory part. Then sec theta. Sec theta is the inverse of cos theta. So in place of sec theta, I can write like this 1 upon sec theta. Sorry, in place of sec theta, I can write 1 upon cos theta. Now in second bracket, again 1 as it is. Cot theta. Formula of cot theta, it is the inverse of tan theta. Formula of tan theta is equal to sin theta upon cos theta. So formula of cot theta is equal to cos theta upon sin theta. This formula we also learn in our theory part, right? Then third term is cosec theta. Cosec theta is inverse of sin theta. So in place of cosec theta, I can write like this 1 upon sin theta, right? Now take LCM in both this bracket. Here LCM is cos theta. So here cos theta is multiplied with 1. So cos theta, sin theta and 1 remains as it is because it already have denominator cos theta. Right? So that two terms remain as it is. So sin theta plus 1 as it is. Here our first term, that means 1. They do not have cos theta as a denominator. So we need to multiply with LCM. So cos theta, then sin theta as it is, 1 as it is, and denominator cos theta. In second bracket, here sin theta, so LCM is sin theta. Now in denominator of 1, there is no sin theta, that means we need to multiply our LCM with 1, sin theta. These two terms already have denominator as sin theta, so it's as it is cos theta minus 1. Okay. So right now, just multiply this two bracket. So denominator multiply with denominator, cos theta into sin theta, and here it is the form of x plus y, x minus y. First bracket. Now look at this bracket, means our x is equal to cos theta plus sin theta, and y is equal to 1. So here you get x plus 1, x minus 1, sorry y, right? This is x plus 1, again this bracket is x and minus 1, 1. So x plus 1, x minus 1 means it is the form of x plus y, x minus y, and answer of this, it's a x square minus y square. That means first term square minus second term square. So what is our first term? It is our first bracket, cos theta plus sin theta, right? So cos theta plus sin theta all square means first term square, then negative sign, and second term square, second term is 1, right? Second term is 1. So first term square minus second term square. Now expand this and use the identity a plus b all square. So first term square cos square theta plus 2 into first into second, 2 into first into second, that means 2 into cos theta into sin theta, and third term square, it is a sin square theta. Here order is changed, but it's okay, right? And 1 square 1, denominator as it is cos theta plus sin theta. Now here we can here we get cos square theta plus sin square theta. We already know one identity, sin square theta plus cos square theta is equal to 1. So in place of cos square theta plus sin square theta, I can write 1 plus 2 cos theta into sin theta as it is, minus 1 as it is, our denominator as it is. Now in numerator, plus 1 minus 1 cancel. So what is remaining? It's a 2 cos theta into sin theta divided by cos theta into sin theta. Now in numerator and denominator, cos theta cut and sin theta cut. So what is remaining? It's a 2. So our answer is 2. Right? Our answer is 2. Initially we can not cut here because cos theta into sin theta, it is in the denominator of this whole term, right? Not only in the denominator of 2 cos theta into sec theta. If whenever separate denominator is not there, at that time we cannot cut it, right? Because here other two terms are also present with 2 cos theta into sin theta. That's why we cannot cut our cos theta and sin theta in that step. Okay. Now third question. Sec A plus tan A, and in second bracket 1 minus sin A. So first of all convert into sin and cos. So in place of sec we can write 1 upon cos because it's the inverse of cos. Formula of tan A, sin A upon cos A, and 1 minus sin A as it is. Then take LCM here. So in denominator cos A is there. So cos A, and we can directly write 1 plus sin A because denominator is same, no need to take LCM. So 1 plus sin A. Now numerator versus numerator. Here 2 bracket is there. That means multiplication process is there. Now in second bracket, it does not have denominator. So we can write 1. Now multiplication of numerator versus numerator. 1 plus sin A, 1 minus sin A. It is the form of A plus B, A minus B. Answer is A square minus B square. Right? 1 plus sin A, 1 minus sin A. So A plus B, A minus sin A. So answer is first term square. First term is 1. 1 square 1. Then negative sign. Second term square. Second term is sin A. So square of sin A, sin square A. And denominator here multiplication is there. So no need to take LCM. But directly they can write denominator as a cos A. Now in numerator 1 minus sin square A. One identity is there. Sin square theta plus cos square theta is equals to 1. Right? Now if we want to find 1 minus sin square theta, then transfer this sin square theta to the right hand side. I already explained this thing in our theory part 2. Okay, so if you don't know, then watch that video of theory part 2. So transfer that sin square theta to the right hand side. Here plus sin square theta is there. So in right hand side it's minus sin square theta. So 1 minus sin square theta is equals to cos square theta. Same thing we need to apply here. Here 1 minus sin square A. So we can write cos square A. So I written here cos square A and divide by cos A. Now cos square A means 2 times cos A into cos A divided by cos A. So 1 cos A cut and we get answer as a cos A. Otherwise we can directly cut this exponent with this denominator. Right? So answer is cos A. Option D. Question number 4. Simple question. 1 plus tan square A upon 1 plus cot square A. Now this is one identity. 1 plus tan square A is equals to sec square A, and denominator it is also one identity. 1 plus cot square A is equals to cosec square A. Right? Now in place of sec square A we can write like this because sec is inverse of cos. So 1 upon cos square A. Same thing in denominator. Cosec is inverse of sin. So we can write like this. Cosec square A is equals to 1 upon sin square A. Now denominator goes in numerator. So in numerator sin A, and denominator of numerator goes in denominator. So cos square A it is in denominator. Now sin square A upon cos square A. Sin theta upon cos theta. It is the formula of tan theta. Here square is there. So tan square A. We can also apply that formula. That means sec theta upon cosec theta is equals to tan theta. I explained this thing in a shortcut trick of trigonometric formulas. Right? Trigonometry part 3. Here tan theta is there. Here sec theta. And here cosec theta. At that time I will teach you that you can go in any of the direction. Means if you want to find tan theta, then goes in anti-clockwise. So sec theta upon cosec theta. Here sec upon cosec is there. So it is the formula of tan theta. I explained this thing in my trigonometry part 3. Okay. So our final answer is tan square A, option D.